This video will cover the concept finding the limit using a numerical approach. Let's begin with the definition of a limit. A limit is the value that a function approaches as the input approaches some value. By value, we are referring to the y value. And by input, we are referring to the x value. This is the mathematical notation for a limit. It means the limit of f of x as x approaches a equals L. Notice x does not equal a, but rather it approaches it. This means that as x gets closer and closer to a, f of x gets closer and closer to L. We will now do an example that illustrates this characteristic of limits. Find the limit of x minus 1 over x squared minus 1 as x approaches 1. We notice that the function is not defined when x equals 1. But this does not matter because the definition of a limit says that we consider values of x that are close to 1 but not equal to 1. We will use the numerical approach to solve this limit. For this approach, we will use a table to find the values of f of x as x gets closer and closer to 1 from each side. First, we will approach 1 from the left side, or when x is less than 1. We will start at x equal to 0.5, then 0.9, 0.99, 0.999, and finally 0.9999. Substituting 0.5 into the function, we get 0.5 minus 1 over 0.5 squared minus 1, which is equal to 0.6 repeating. By rounding, we can just write it as 0.66667. Substituting 0.9 into the function, we get 0.9 minus 1 over 0.9 squared minus 1, which is equal to about 0.52632. Continue this process for the rest of the x values.
Okay, so I completed calculating the rest of the three x values. Does this look correct?
Yes, you found those values correctly. Now let's make another table. This time we will approach 1 from the right side, or when x is greater than 1. We will use the x values of 1.5, 1.1, 1.01, 1.001, and 1.0001. We will not go through every substitution step, but I encourage you to do it independently and check your answers with the ones we provide. Here are the values we calculated for f of x at each x value. Comparing the two tables, what value for f of x do we approach as x approaches 1?
When we approach 1 from the left, we seem to get closer and closer to 0.5. When we approach 1 from the right, we also seem to get closer and closer to 0.5.
Exactly. Therefore, the limit of f of x as x approaches 1 is 0.5.